So today we're solving quadratic inequalities. So these problems either have less than, equal to, or they might have greater than or greater than equal to. So our solution set can be a set of numbers. To solve a quadratic inequality, what we're going to have you do is first find the roots of the corresponding equality. So the first thing we're going to do is change the problem to an equation, sort of down on this side. So here I have x squared minus 2x minus 15 equals 0. And this is going to find the roots. So factor. We still want them to multiply to 15. So 5 and 3 should give us our minus 2 in the middle. Split and solve. So remember, these are the roots. These are where the graph crosses. Crosses the x-axis. Smartboard gets bad down here. Crosses the x-axis. Okay. So what we're going to do today is we're actually going to take our graphing calculator and we're going to put this into the calculator. So I want to hit y equals and x squared x squared I'm not seeing my buttons. There we go. X squared minus 2x. It is just not reacting well here. I don't know. Let me try one more time. X squared. I need to go slower. Minus, there we go, 2 x minus 15. All right, now we want to make sure we have a decent window here. Let's do a zoom 6. And there's our graph and a table of values. And my poor key press history is terrible right there. I'm going to get rid of that. So here's the graph, and you can see it indeed crosses at -3 and at +5. And we have that here as well. Okay? So when we put in the equation, we can get a beautiful graph. Well, let's back up a minute. We actually were solving an inequality, remember, and we're looking for where this parabola is less than 0. So there's a couple ways that we can interpret this. First of all, we can look at the being less than 0 as meaning we want to look below the x-axis. If I just look at the picture and I shade this section below the x-axis, then that is the section that is my solution set. And I can tell from that shading that I have shaded everything between -3 and 5. So that interpretation gets us to the answer very quickly. Another way to do this is to say that we have taken the x-axis, and we know our graph hits at -3 and +5. And and we know it's less than, and we have 3 different sections. So this says it divides our number line into 2 or more intervals. It says test a number from each interval. And if you get a true statement, then that part of the interval is shaded. And if you get false, that is not shaded. So if I look at a number line and I try maybe 0 in here and 10 out here and -5 out here. If I try these numbers in my original problem to see if they're true, then I can tell where to shade. So let's try 0. 0 squared is 0. Minus 2 times 0 is 0. Minus 15. -15 is less than 0. That's true. So I should be shading here. And we are open on -3 and open on 5. So 0 worked. Let's try 10. 10 squared is 100. Minus 2 times 10, minus 15. Is it less than 0? So we have 100 minus 35 is less than 0. From that, we get 65 is less than 0. That's a false statement. So I don't shade in the section where there's 10. Get rid of that. And then we have -5. Checking -5 in the original. -5 squared is 25. Minus 2 times -5 is adding 10. And so I have 35 minus 15, and that's 20, which is not less than 0. So I'm not going to shade in this section either. So what I have here is shading from -3 to 5, and we looked at that conjunctive inequality the other day, so we know that's our answer. Same answer that we got doing it the other way. And the last way that you can do this is actually on your calculator and using the calculator's ability to put in that less than sign. So now I'm going to do this, and we're going to get this. Let's do that together on the calculator. So I'm still going to go to the y equals, and I've got the quadratic in there already, so I'm going to arrow through it, although it's just very unresponsive. Not that one. Get all the way to the end of it. All the way to the end of the 15. There we go. And we're going to hit our second button and use the test menu, which is above math. Second, math. All right. And from there, we're going to choose the one that is less than. So that's choice 5. And it puts a less than right in there, and then a 0. When I hit graph for that, notice now I get actually the shading between -3 and 5. So we get this on our graphing calculator. And this, of course, is what you should be seeing. So there's some interesting ways to use the calculator to try and find the solution sets for these inequalities. All right, we just gave you 3 ways to do this problem. Let's try another. Although I don't think I want to use the calculator. So find the solution set of x squared plus 6x plus 8 is greater than or equal to 0. And this now says if x is an element of the set of integers. We'll talk about that. Let's take x squared plus 6x plus 8 equals 0. roots are -4 and -2. Okay. Now we could say we're going to test a number in each section. We could interpret the original inequality as greater than or equal to 0. And we could put the inequality in our calculator. Let's do all three ways again. This one is greater than or equal to 0. So we're going to look above the axis and actually equal to the axis as well. Remember, this one was less than 0. Just comparing the two now. This was less than 0, and we looked below the axis down here to think about our number line. Here we're going to look above the axis. So if I look above the axis, then I'm shading this section here and this section here. Now let's think about that. We know the graph is hitting at -4 and at -2. So if I shade this part, these x's are greater than or equal to -2. And if I shade this part, those x's are less than or equal to -4. And notice that those two separate parts, so we need the word or. Using the method of checking around the critical points, we might decide to check, you gotta be really good with your number line, 0. We might check -3, and we might check, let's go crazy, -10. So checking 0, back in the original, I'll show my work down here. 0 squared plus 6 times 0 plus 8 is greater than or equal to 0. So that's 0, that's 0, that's 8. 8 is greater than or equal to 0? Yes. So I'd actually shade in this section. And these equal to -2, and -4 as well. So I'm shading there. And that's kind of a big clue as to what's going to happen next, but never assume. Let's check -3. -3 squared plus 6 times -3 plus 8. We're checking if it's greater than or equal to 0. So we've got -9 plus 8, which is -1. -1 is not greater than or equal to 0. So we are not shading there. And checking -10. -10 squared is 100 plus 6 times -10 plus 8. Is that greater than or equal to 0? We've got 40 plus 8. Oh, my smartboard's bad down here. So 48, definitely yes, is greater than or equal to 0. Yes, we shade this way. Now you can see this answer, this shading, is the same as these two parts. Now last but not least, let's put the inequality right into the calculator. So exactly what the problem says, x squared plus 6x plus 8 is greater than or equal to 0. I'll go to my y equals, clear it out. You're probably going to be quicker than I am. This unfortunately lags a bit. And to get those inequalities, you go to second, and then to math. And this time we want greater than or equal to 0. And we want to know what's above the axis, what parts are above the axis. And you can see the shading, the number line shading. If you can count those little dashes, go to the right of -2 and to the left of -4. Okay, one more. So first thing to notice here is that this quadratic is a little bit different. -x squared plus 7x minus 10 is less than 0. So one of the first things you might want to do is multiply through by -1. If we multiply or divide by a negative with an inequality, you know it's going to flip the sign. So we're going to get x squared minus 7x plus 10. We're going to flip our inequality, and -1 times 0, of course, is still 0. So that situation, which might be something you're very tempted to do, is shown down here as the graph. It would be a graph of a parabola. Let's factor the quadratic, set equal to 0, and find the roots. Multiplying to 10, maybe 5 and 2. Negative, negative. Beautiful. So our roots are 5 and 2. You can see, sure enough, that's hitting at 2, hitting at 5. Where is that graph less than 0? So that graph is below the axis. From 2 to 5. From 2 to 5, and open on 2 and 5, means that our solution is 2 is less than x is less than 5. Our solution set. What if you didn't multiply through by -1? If we just put, let's see if I can move this, whoops. If we just put the quadratic as is into the calculator, then remember when the a value in front of a quadratic is negative, it means that the parabola will be upside down. So you can see on your calculator you would get a parabola just setting y equal to -x squared plus 7x minus 10. Now that original question has a greater than 0. So if we use the original equation, we'd be looking above the x-axis. Let's see if that works. The section above the x-axis is from here to here. And 2 and 5 were still the roots. And so we still get 2 is less than x is less than 5. And again, don't forget the third way that we might do one of these is to put the entire inequality in as is and look for the little shading on the graphing screen. And that's it. That is it, kiddos. See you tomorrow.